Hi guys, Miss Scott here again, and here's your bad joke of the day. Why couldn't the lifeguard save the hippie? Well, he was too far out, man. Alright, so it's a pretty bad one. Let's jump into 9.3. So in the last lesson, we talked about translation. So we were sliding figures around. In this lesson, we're going to learn how do you reflect a figure over a line. So we've got 4 rules to do that. Before we get into any rules, if the line that you're reflecting over is either vertical or horizontal, all you have to do is just mirror the image over. Okay, so the line of reflection in this first example, they're asking us to reflect triangle RTI over line L. So this line L is the line you're reflecting over. All right, and then the prime notation we talked about last time, where when you move something, you put that little apostrophe after it. Okay, and then a reflection is simply a mirror like transformation. Okay, so it's like if that object was looking in a mirror, what it would look like. All right, so if we reflect I from 1 unit to the left of this line, I prime is going to be 1 unit to the right. R is actually going to be in the same place as R prime because it's on the line of reflection. And then T is 2 units to the left, and then it's going to be reflected over here, T prime, and we just connect those 3 segments. So triangle R prime, T prime, I prime is the reflection of triangle RTI. All right, so there are 4 rules that if you're in the regular coordinate plane where 0, 0 is right in the middle, we can use these 4 rules. If it's reflected over the x-axis, then the image is A stays the same, and then the y value becomes opposite. If you're reflecting over the y-axis, A becomes opposite and B stays the same. If you're reflecting over this line y equals x, you flip-flop the B and the A. And lastly, if you reflect over the line y equals negative x, you flip them and you make them both opposite. All right, so let's use those rules here. In example 1, we're going to graph the reflection of quadrilateral ABCD over y equals x. So if we look above, our rule is this. If you start with x comma y, you're going to take your x and your y and you're just going to flip them. Okay, so I'm just writing down this rule from up above right here. This 3rd rule is the one we're looking at right now. So if we look at that, what I always recommend doing is just writing down where your points are. So A is at negative 3 comma 4. B is at negative 2 comma 0. C is at 2 comma negative 3. And D is at 3 comma 3. All right, and remember our rule is just going to flip the points. So A prime is going to flip and become 4 comma negative 3. B prime is going to flip and become 0 comma negative 2. C prime is going to flip and become negative 3 comma 2. And D prime is going to flip. Notice when D prime flips, it doesn't change. It's still going to be 3 comma 3. Okay, and then we can just graph those 4 points. So A prime is over 4 and down 3. So this would be A prime. B prime is over 0, down 2. There's B prime. C prime is left 3 and up 2. And then D prime stays in the same spot. So we're just going to put it right on top of itself. And then we just connect those lines, or those dots. So we get the same shape. It's just in a different spot. All right, so now just as kind of to show you what's going on here, the line y equals x is just a line with that starts at 0, 0 and has a slope of 1. Okay, so that would be this line here. So if we draw in the line y equals x right here, this line y equals x, you notice that it's kind of a mirror image. Like B was here and now it's over here, so it's the same distance from that line. Say with A prime and A, they're the same distance from that line. And that's why D and D prime are in the same spot, because D was on the line of reflection. Anytime a point is on the line of reflection, it does not move. All right, let's look at example 2. So here they say graph triangle ABC. All right, let's start with that. So graph ABC. So A is at negative 1, 2, 3, 4, 5, and then up 2. So there is point A. B is over 1, up 2. And C is over 1, up 4. So we've got this right triangle here, triangle ABC. And we are asked to do a couple things here. Step 1 is we're going to reflect over this line y equals negative 1. And if you remember from algebra, this is a Hoy line. So it's horizontal when it's got y equals. So the line y equals negative 1 is a horizontal line through the y value of negative 1. All right, so this is the line y equals negative 1 right here. All right, so if we flip triangle ABC over that line, we just have to figure out how far above each point is and flip it below. So A was 3 above this line, so A prime is going to be 3 below that line. B was 3 above, so now it's going to be 3 below. And C was 1, 2, 3, 4, 5 above, so C prime is going to be 5 below. So if you did that right, it should be the same shape, just tipped over that line. All right, so we did step 1. We reflected over the line y equals negative 1. And our last step is telling us to reflect over the line x equals 4. So this is a vux, which if you remember from algebra, is a vertical line if it's x equals. So the vertical line x equals 4 would be over 1, 2, 3, 4. And it would be this line going through the x value of 4. All right, so this is the line x equals 4. And then we would go from left to right. So C prime was 3 to the left of that line. So C, we'd call that C double prime is 3 to the right. Same with B, it was 3 to the left. It's going to be B prime prime. It's going to be 2 dashes there. All right, and now A is going to be a little bit off the graph, so just do your best with this. A is 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. So A double prime is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Just try to estimate where 9 to the right would be. So there's our A double prime. And then we connect those to get that triangle. All right, so 2 reflections in one. If you do another reflection, you would call it A triple prime, B triple prime, and C triple prime, but we're not going to get that far. All right, we have one last example. Let's take a look. All right, when delivering pizza, Biff needs to park on the street, which this right here, this horizontal line is the street. So that's the street. To minimize the distance to walk to each door, which the doors are these 2 dots here, we want to know where Biff should park. Well, here's the steps to figure that out. it deals with reflection. So the first thing we're going to do, I'm just going to label this point A and this point B. So we're going to reflect point A, and you can pick either one of the 2 points. So you could have just as easily started with point B here, over the line. So that's your first step. Let's go ahead and do that. So we're going to take this point A, here it is, we're going to reflect it over the line so that this is the same distance. And this is just a sketch, so you don't have to worry about it being super, super accurate here. And we're going to call this point here A prime. All right, so this distance is the same as this distance. All right, well, that's our first step. Our second step is going to be to draw a segment from A prime to B. And if you would have picked B in the first step, it would have been from B prime to A, depending on what point you flipped over. All right, so step 2, draw in that segment from A prime to B. And then where we would want our solution is, it turns out that the intersection of A prime B, that segment you just drew, with the street, or the line of reflection, is what we call that in math, would be, or is, the shortest distance. So it's the shortest distance to both A and B. All right, so it turns out that this point here would be the shortest distance to A and B, so Biff should park here. Now, here's why it doesn't matter which point you would have picked. Let me do this in a highlighter here just to kind of show you the other route. So what if we did this way? What if we took this point B? So if we took point B and reflected it, so I'm going to try to estimate the distance there. So this would be our B prime, and we, in step 2, would draw a segment from B prime to A. So we're going with what happens if we would have picked the other point. Well, if you look at that, if I draw that segment in, let me try that again, that did not work out super well. If I draw that segment in, it turns out that it's still going to cross at the same spot. So it doesn't matter what point you pick, as long as these are the same, you still get that intersection to be at the same point. All right, so just a little practice there with reflections. Make sure you guys like my video and just subscribe if you can, and we will see you guys next time. All right, take care.